Hi guys, welcome to yet another episode of the Spring AI series. And today's session is going to be a continuation of what we started covering, the Spring AI Chat Client API. So a fluent API that enables you make the calls to the AI model. So just provide the abstraction for you to easily make calls to the models, and yeah, off you go. You can start interacting with it. So in the previous session, we built a simple endpoint that ideally exposes or just like shows us the use of that. So let me bring this guy down here. Okay, fantastic. So shows how to inject a chat client, how to inject it using the chat client builder. Of course, this is constructor injection. You build the instance for it, and then you can now reuse this client here by passing a prompt. So we talked about the prompt, which ideally is just like defines the system prompt. So it tells your model what it's supposed to do, the restrictions and whatnot. So ideally, there are a bunch of things you're supposed to do here, and there's a better way of doing this. But for now, this acts as our system prompt, and then this is where our user prompt, the prompt that the user provides, is put, and then we have a dot call, which makes the call to the model, and then last but not least, we have the dot to content, which returns back the response from the model as a string. Remember, we said that. So yeah, that's ideally it. The 30 video, um, 30 minutes video would have been made shorter by just talking about this. But nonetheless, in today's episode, we'll be exploring a continuation of the chat client API. So there are a bunch of things it could do. And the next step, so we've already done this configuration of the chat client. And the other bit that I forgot we did last time was we talked about the application.yaml. How do you configure with specifically Olama? Because that's what we're currently doing. And you can see in my POM file, I had the Olama starter, then I just ai.olama, and then you put the chat, the model there. Ideally, this also should be somewhere there, so it should be somewhere there, which is okay. So the model is that, and then I just need the base URL. So the others would come in later on. But ideally, that's how you configure a simple thing, Spring AI. Okay, so what I want us to cover today is we've already created a chat client, and now what if Ian, as a developer, wants to interact with multiple models? So if you want to operate with multiple models, there are several scenarios that could bring about this. One is using different models for different types of tasks. So you have, say, you want to your application to have an aspect of multimodality. So your one model cannot support all these features like image generation, text. It can't support all of them. So you can have a model like Llama 3 that supports only text. So if you want to add more power to your application, you need to inject a model. Either you bring a model that has the aspect of multimodality, or you bring other models that are specific to specific tasks. So different types of tasks, that's one. You want a complex reasoning and a faster model, or you want cheaper models for simpler tasks. I also want to implement a fallback mechanisms when one model service is unavailable. So say, for example, your Llama model you deployed somewhere is down, you'd want to um, reroute the traffic to, say, Anthropic. The same applies to when you want to perform A/B testing for different models or configurations. You also want to provide users with the choice of models based on their preferences. So, which one do you want to use? Do you want to use Anthropic? Do you want to use uh, ones from Azure Foundry? Name them. When you also want to combine specialized models, you can have one for code generation, another one that is for creative content. Like GPT, to me, is kind of creative when it comes to text. So you might want to use Anthropic for code generation, and then you might want to use ChatGPT for content creation. So it depends on your want, and yeah, whichever model you prefer. So this one, we by default, Spring AI injects the no provides or configures the chat client builder. That bin is provided there for us. But now, if you want to work with different types of models, so you need to have this in your application.properties or application.yaml. So I just come to somewhere like this, Olama. So I need to add under AI. I need to add here chat, and then chat client enabled. So I need to have it as false. So I need to have it as false. So the chat client is not enabled by default. So that means that you have to configure it on your own. Of course, via a config file, which we'll look into later. So that is what you're supposed to do. And then so you have to create you'll have to create multiple instances of the chat client, and then you can inject them whichever you need at a specific time. So multiple chat clients with a single model type. So yeah, here we have, you create a chat client instance, and then the chat client takes in, when you say .create, it takes in a specific model. Or you use the builder for more control. You can say chat client builder chat client dot builder, and then you pass in the model there. And then yeah, chat client, custom chat client, you have the builder here, you pass in the prompt. So yeah, it depends with the kind of how you want to do it. So you create a chat model, so the chat model could be specific. So we can just look at that chat model in just a sec and see what it does and where it comes from. So you can say chat model. Yeah, we can just have this, and then I'll click on it, and then yeah, so fair enough, it's like they have docs. I'm just being sarcastic, man. Yeah. So chat model extends the model. Streaming, yeah, and then okay, model. Okay, it's an interface. Yes, it extends the model. So let's see if model has some docs. Model interface provides a generic API for invoking AI models. It is designed to handle the interaction of various types of AI models. Yeah, Mark Pollack. Yeah. Yeah. The interface uses Java generics. Yeah, that's okay. And then yeah, so I have this other one, which is streaming. So the streaming model interface provides a generic API for invoking AI models with Spring. Okay, so ideally the chat model is just like providing us with a way of interacting with like generic API for invoking AI models. So we can invoke any AI model designed to handle the interaction of various types of AI models, abstracting the processes of sending requests and receiving responses. So there's the model, and then there's the streaming model where you get yeah, you can get them in streams. So Flux and Mono kind of thing. So that's for yeah, the reactive way of doing things. So yeah, that's how it looks like, the chat model. So you can specify the model there, and then let me see if I'm missing anything. All right, so I'm getting this because I guess because I did the other thing there. So let's just continue. So this is how you can do it. And then when working with different types of models, you're supposed to do this. So let's just create a chat client config here. Yeah, so I need a config chat client config. Yeah, that should be it. And then you just mark it as a configuration file. Yeah, it's a configuration file. And then afterwards, we now need to create like we need one for, let's see what they have. Chat client for OpenAPI, and then we have one for Anthropic. So I'll create one for Olama, and then I'll create the other one for Anthropic. Yeah. So I'll say Olama. Yeah, I'll just say something like a public chat client. Yeah, chat client, and then I say Olama client, something like that, and then I'll just pass here Olama. Olama chat model. Yeah, you pass in the model and say this is Olama, and then yeah, that's ideally it. So I'm supposed to import this from Spring Framework, and then I'm supposed to return chat client builder dot Olama. So I'm supposed to pass in Olama, and then I'm supposed to use the creator, or yeah, you can either use the builder. Let's say builder, so that builder dot. Okay, you can't do that here. So you're supposed to say chat client dot create. Yeah, we pass in the model Olama like that. I want to explore the other option where we said I want to see chat client builder, builder. So when you say builder, you're also passing a chat model. Yeah, you're also passing a chat model, and then yeah, it creates. I guess they're just doing the same thing. You can also also have this builder that takes in a chat model, observability registry, chat client, observation. Yeah, we'll get there when the time is right. But ideally, you can do with either. Yeah, that's Olama, and then I'll say Anthropic here. Anthropic. So we just say public. So I'll just copy this method here like this, like that. So say anthropic client, and then I need an anthropic. Okay, so I'm supposed to have the dependency for anthropic. So what I'll do is I'll come to POM. I'll come to POM file, and then I need to add the starters. Yep, I need to have the anthropic cloud. Yep, that's about it. Inject it. Reload the POM for me, please. Resolving the dependencies. I just hope it works out, man. Okay, as we wait for it, yeah, anthropic. Anthropic. So it's still resolving the dependency. So let's give it a couple of minutes or seconds. Yeah. Okay. Let's see if everything is okay. It should be, because it's added it here, the starter for anthropic. Yeah, that should be fine now. No, it's not fine. Okay, anthropic chat model, yeah, and then we call it anthropic like that, and then here we inject anthropic. Yeah, so what I need to do is just do the alt enter, import it from anthropic. Yeah, that's what we're supposed to do. And then now we can inject it wherever using the at qualifier. So at qualifier, whenever you have like a couple of dependencies, or you need to inject like a few variations of a thing, you just need to use that qualifier for that. Yeah, so we can ideally, what we can do, let's see. So we have the chat client inserted like that. So we have that. And then we can say here at qualifier, and then put it like this. So are they supposed to be bins, or they're just, yeah, they're supposed to be bins. Yeah, got that right. They're supposed to be bins. So I'm supposed to put here a bin for this, and this is also a bin. Yeah, it's fantastic. And then in the controller, how do I pass that again? I put the name is OpenAPI. Okay, so sorry about that. I'm supposed to have this one here, and then the name is let's see, what's the name for this? This, for example, is Olama client. Can I specify the name? Yeah, I can specify the name. So I can call it this Olama client. I can also call this bin anthropic client. So I can inject either. So I can have the controller there, and then in the qualifier, I can just say anthropic. I don't have anthropic configured, so I'll say here Olama client. And then I get an error. What's that? Olama client, or am I doing it wrong? At qualifier, a chat client. Okay, so I'm supposed to use the chat client. Okay, so yeah, we're just learning, man. Just learning, like that. And yeah. So the chat client like this. And then I guess here you're supposed to just say client, if I'm not wrong. Yeah. Well, let's see if something is amiss. Do you really think something? I think it should be fine. I just think it should be fine. So the client, you put that qualifier there, and then layers. You can have both of them, and then if one fails, it can resolve to the other. But you get the idea. So yeah. So what we have is this one, and then you say a chat client. You create it. So if you have two, you can say according to this, you create a chat client, and then how do you select the model? One is for OpenAPI. So if the choice equals to one, the chat client equals to OpenAI. You use that, and then if else, you can just do that, and then you can enter your question there, and then it answers you. This is just like a simple Java application. So yeah, that's how you do it. So let's look at this other one. Um, so it's saying a multiple OpenAI compatible API endpoint. So the OpenAPI and OpenAI chat model classes provide a mutate method that allows you to create variations of existing instances with different properties. This is particularly useful when you need to work with multiple. Okay, so there are variations of OpenAI. You can have OpenAI and OpenAI chat model. Okay, they provide variations. So then they have a mutate method that allows you to create variations of existing instances with different properties. So let's see. So you have a logger, that's fantastic. So this is a multi-model service. We have an OpenAI chat model. This is the base chat model. And then you also outwire an OpenAI API. This is the base OpenAI API. So let's see. So try. We derive a new OpenAI API for Grok, llama 3. So OpenAI Grok is equals to the base. This one, dot mutate. You pass in the base URL for Grok. Pass in your key, and then yeah, you get it. Then you derive an OpenAI API for OpenAI GPT-4. Oh, okay. So you have a variations of an of OpenAI compatible models. Yeah, so I see it. So derive an OpenAI chat model for Grok. So this you're just setting the things, APIs. Okay, you're setting the APIs, and then now the chat models. So there's a model Grok that's compatible with that. You pass in the Grok API. So you say OpenAI chat model, Grok model, base chat model dot mutate. So I see. So what they are doing is there are various variations. So OpenAPI can have like different flavors. So like we have Grok, we have OpenAI, yeah. And then now when you pass in your OpenAPI, now you need the model. So OpenAI API chat model. And then for these two that you've created, you need to pass now the chat model. So when you say now the chat model dot mutate, you're supposed to pass in the OpenAI API, which is the Grok API. This is which you provided here, and then you're supposed to also derive the same for Open this one. So I guess we can try that one. Let's just try. Let's try in. But I wonder where I'll use them though. I just wonder. Mutate. So I can inject um, private uh, open AI. Okay, so I need to add the dependency for that. Just go to the status. Open AI. Yeah, that one. So as it resolves the dependencies, so let's just see what they are saying. Something else they're saying in their docs. So it already resolved. So let's see. Open API like this, and then we also have this one. private. You can have this as private. We have the Open AI chat model one. Then now here we need a constructor. So here I'll just use autopilot one. Public this one muted models. Yeah, that's fantastic. And then yeah, thank you. Fantastic. And then we can have a method called mutate public static. We need a static, so we can just have it as static. Static. What does it return? What does it return? So it returns it's a void. It's a void, and then it's called mutate client flow. Okay. Uh, uh, like that, and then so we're trying. So we try. So we start with the Open AI API. These ones are very confusing. Okay, so start with the Open AI API. So we say Open AI API. We say something like grok. No, it's a queue equals to say Open AI API dot mutate, and then here you pass the base URL. The base URL. I'll just leave this as empty for now because I don't have not prepared. So and then I pass in the API key. Then yeah, I'll just do the build here. That's fantastic. So here I'll just pass in the API key as an empty string like that. I can just create the other one, or let me just create one. But the idea is for you to see the mutation. So what else do I need? So I can create the one for. I just need to create another one. OpenAI API, and then I say OpenAI equals to, I say OpenAPI that one dot mutate like that. I can say dot build, so that's okay, like this, and then I can pass in the keys. I can pass in the dot base URL is that. I pass in an empty string for now, and then pass in the API key. So yeah, and then after that I'll need to now the chat models. So I use the Open AI chat model like this. I just say grok model like that equals to. I use the grok API. So I'll say grok. What did I call it? Grok. Yeah, I did the wrong thing. Grok dot, and then I'm supposed to mutate, and then after mutating, I say a dot. Wait a minute. Chat model grok, and then am I supposed to really mutate? Let's see. Yeah, pass in the base URL, mutate, and then say dot open AI API. Okay, and then you pass in that one. Fantastic. Say dot open. Okay, it's like the support ended, yeah? No? Open AI chat model. Open AI chat model. Okay. So I'm supposed to use the base model that I provided. Okay, I see. Okay. And okay, I'm now understanding it. Not cramming. Yeah. So mutate even this one. Yeah, I use this Open API. I named it wrongly, but it's okay. So I'll say dot open API. This is for grok, so I'll just say here grok like that, and then I need to also do something here. I say a dot default. Is it default options? Yeah, default options like that. What am I supposed to pass here? I'm supposed to pass in the OpenAiChatOptions.builder and then provide the model and then provide the temperature. Okay, I see now what they're doing here. I see it now. So this the default options, they define the kind of behavior that your model will, you just like defining the parameters that you would have otherwise defined in your POM. So no, in your application.yaml. So if here, for example, I was to say something like a temperature, I don't know if it's supposed to be here. Yeah, but it's somewhere around there. So you can define the temperatures and whatnot, just like telling us how your model would behave. Yeah, so we can say here open model.options.builder like this. So I need to remove this one here, and then yeah, import that one, and then here now here we add a few things. The model name, model name is something like let's see, for Grok, let's take this one here, the one that provided. Yeah, this, yeah, that's fantastic. And then you can add the temperature like that. You can have it at 0.7. So it depends with how you want your model to behave. Then afterward, you can just say dot build like that. So I will not do the other, but now I now understand what's supposed to happen. So you have the different variations of the model. So we'll create the other one like this. We'll create the other for OpenAI for GPT-4. So you also specify this, specify the temperatures, and then the simple prompts for both models. So what is the capital city of France? So you can get responses from both of them. So you just use the chat client dot builder, and then you pass in the model, the Grok model, yeah, this model, and then you pass in the prompt, this prompt here, and then you have call content, and then it gives you both responses. So I'm trying to see where I'd use that, but yeah, I guess it's just showing us how this works. Yeah. Or let's ask AI where we could use, because I honestly don't know. So yeah, we have this one here. So I'll just say cloud. Hi. In what scenario will one opt to use this kind of configuration in Spring one? I'm so shit in typing. Spring AI project. So let's see. Understanding the mutate pattern in Spring AI, great question. Yeah, and this is really elegant pattern that becomes valuable once you start building applications that go beyond single provider. Okay. We're cruising nicely. But the core idea, before jumping into scenarios, let's make sure you get the mechanics clear. So what's happening here is you have one auto-configured OpenAI API and OpenAI chat model bin from the application or properties. Yeah, so we've configured. So assuming we've configured that, and then you're using mutate to create derived copies with different settings. Think of, okay, you're using mutate to create derived copies with different settings. Think of mutate as a builder that starts from an existing configuration instead of starting from scratch. Yeah, so okay, makes sense. And then it's the same pattern Spring uses for web client and REST client. Okay, the key insight is that many AI providers today, Grok, Together AI, Anyscale, yeah, yada, those one all speak the OpenAI protocol, OpenAI API protocol. So one OpenAI chat model can talk to all of them. You can just swap the base URL and API key. So let's just get into what you'd actually. Scenario one, cost optimization via model routing. So this is probably the most common real world use case. Different models have wildly different costs, and not every query deserves a premium model. So imagine you're building a customer support. This one, a simple frequently asked lookup. What your yeah, doesn't need GPT-4. It needs a cheap llama model on Grok handles. Yeah, that one. But when the user asks a nuanced question requiring reasoning, you can scale it to GPT-4. So the first one is this one, model routing, cost optimization. Scenario two is fallback and resilience. So AI provides go down. OpenAI has multi-hour outages. So Grok uh, has had these limiting storms. So with this pattern, you can wrap your primary model call in a resilience for J circuit breaker, which you already know well from your IntelliQ work. And when it opens automatically fill over secondary provider, okay. So we have A/B testing for model evaluation. When you're evaluating whether to switch models. So say deciding if Llama 3 70 billion is good compared to GPT-4 for your use case. Okay. So the first one is cost optimization. The other one is fallback and resilience. So in case something happens, do you have somebody you could lean to? And then, yeah, uh, with this pattern, you can wrap your primary in a resilience for circuit breaker. Yeah, we talked about that. A/B testing, you're testing which one is better. So this becomes especially useful especially for your, okay. Specializing models for specialized tasks. So yeah, and then you have multi-tenant applications with bring your own key. So you bring, okay, users can bring their own keys, and then the directory flags. Imagine you're building a SaaS where each customer wants to use their own API key for billing, data privacy, and compliance reasons. So you can add code one key into the auto-configured bin. You need to mint a new OpenAPI request using the tenant's credentials. So the .mutate pattern is perfect here because you derive from the base configuration, keeping all the sensible defaults like timeouts, retry policies, and whatnot. Local development. Okay. The try and catch that swallows exception and only logs is a demo level pattern. So let's, okay, because I don't know and you might not know as well. So let's bootstrap a simple app. So let's build something small that shows the application of this pattern, and yeah, of this pattern. And which other pattern have we seen? We've also seen this other pattern that's called the chat client for different model types. And this too. Yeah. Let's see. So yeah, we can definitely use AI to help us learn. The goal is to really understand what's happening at the end of the day. We come from nothing to something, man. Okay. Da, 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 da. Mhm. Okay, as we wait, I hope you now have an understanding. So there are various scenarios where you'd opt to do that. You need fallback plans. You want to have models that would be answering simple things. You also want to have models that would be uh, like your multi-tenant application, such kind of scenarios. That's when you'd use all these things. So the chat client has a lot of things. It has a lot of things. Yeah. So the next one is the Fluent API. So we talked about this, allows you to create a prompt. So prompt, this method with no arguments, let you start using the Fluent API. System message, and then the prompt with a prompt. This method accepts a prompt argument, letting you pass in a prompt instance that you have created from the prompts and Fluent API. Prompt string content is a convenience similar to the previous overload. So just like method overloading, yeah, but it pass different parameters. The chat client API offers several ways to inform that the response. So this is where you get the response. So returning a chat response. So there's a chat response class as well that we don't talk about often. So you can return a chat response. So you just do a chat response and then it comes with metadata. So this is when you're looking for metadata. And then now the other important and the most important one is when you want to your data to be returned in form of a JSON, specific JSON, like you're dealing with actors and you want your response to look like this actor, and then you have a list of movies. So return a record. So you can do this actor actor films at client.prompt, do this, and then you can do the dot call, and then at the end you do a dot to entity. So I guess we'll do that. Let's see if this thing has finished generating. It hasn't. Okay. As we wait for that, we can possibly, let's just say catch here. Yeah, that's about right. So shift. Yeah, yeah, formatted the whole thing. So let's go to the chat controller and try to create a record. So we'll just create a record here. Um, We create a record of a person like this, string name and age. That's okay. Okay, like that. And then we can have a get mapping here. Oh boy, get mapping like that. You can just say slash person. Uh, yeah, you can just say a public person. So this returns a person. So I can just say here return say chat client dot say dot. I give a prompt like that. So I'll leave that, and then I say dot call the dot user. I'll lead a prompt. So this is at request param. A request param like this, a name, and then I can pass here. Let me just call this the user input, like that one, user input, like this. Pass it here, and then we call, and then we say dot to entity like that, and then we specify it's a person. So person, and then class. So yeah, so if we make a call to this endpoint, we'll get the output as a JSON in form of a person. So let's see the error. Uh, is this now? Hi. All right. So that's ideally it. So ah, okay. I have the client here. It's not chat client, it's client. Yeah, that's about right. So I'm supposed to get the response in form of a JSON. So let's see. So the first thing it's gonna do is it's going to, when I run it, it's gonna try and run Olama. So application run fail, class path. Yeah, I have a couple of things. OpenAI, audio speech. Oh, the actual. Huh. Okay, I see what you did, man. Yeah, so the issue really is I have these things here, so I'll have to remove them. Let me just see. I was just experimenting with these things, so I'll have to comment them out. So I'll have to comment this one. This is Llama, this is Anthropic. So let me comment this one out. Uh, to say that, I need to comment out this as well. And then at the same time, so not very good practice, I'll come to this one, these models, I'll comment them out, and then I'll rerun. I hope it doesn't fail. Anthropic does not exist. Oi, 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 oi. Yeah, it started, so I can make the call to that specific endpoint. So I'll just come to the controller here, and then yeah, so I'll pass the user input as okay, create a random person, something of the sort, and then I'll make the call. Now this call is gonna take centuries, because if I go to my terminal, it's when now Olama would start picking up. So say Olama, yes. Now this is when Olama has started now, so it will have to take a couple of minutes for it to generate the response. So as we wait for it to generate the response, which is going to take a while, I'll come here to see whether this thing has completed. I don't want a zip file. Yeah, who wants a zip file, man? Yeah, so we have two things we're supposed to wait for. Yeah, so as you can see, it generated the response. It generated the response. So we see it returns now an actual JSON. As you can see, the content type is application slash JSON, and then we have the name is Sophia Flynn, and then the age is 32. So you might wonder, where is it getting that record from? So when you say record person, pass the string and the name and the age, it passes them as the specified fields. If I can say int here, and then rerun the app, and then come back to this. Yeah. So I could do the same. I could rerun it. So you can say it will generate the person with an int as the JSON type. So let's see what my brother here has generated. Olama is very funny if you're using it locally. So you get an internal server error, which is very interesting. So let's see what the issue is really. Will not pass the given text to the desired type schema. Type object age integer type string name. Serialization failure. Cannot map null into type int. Okay, so let's try again. Yeah, so that was just because it's a random, it's generating it randomly, so it might have had a null age, but now you see it as an integer. So instead of like in quotation like strings, so you can return any type that you want. Okay, so let's see what my brother is generating here. So we have the OpenAI. So we have the OpenAI starter. So this starter might come with like a bunch of things in it. And then the other bit, so let me just zoom in a little bit. The entry point, this is the entry point. Okay, so let's see. Role abstraction. This is where we have, think of it like, I don't want to think of it like that. So this tiny enum is the keystone for the entire design. Before any code gets written, a good boy, Grok versus OpenAI. So I have a model role. So defines if it's fast, cheap model. For simple, we go for the 70 billion parameters. Grok. If it's code, we go for a code tuned model. If it's reasoning, we go for GPT-4. And then we have the router. So the router's job is to look at the question and decide which role should handle it. I'm deliberately keeping this keyword. Okay, my guy, thank you, thank you, thank you. One subtle thing worth noticing is the order check matters. A question like why is my Java code broken contains both a reasoning keyword like why and a code keyword Java. We check code first because when both apply, the code specialized model will give a better answer. Yeah. So we check and a code keyword, that's important instead of the reasoning keyword. That makes a lot of sense. So it was worth it reading it. So here we decide which model will handle a question, and then we have keyword suggesting a coding question. We look for this in the question text or to flag the code role. So yeah, we have a list of words. So code, function, class, method, yada yada yada, all this. We could make the list very long. And then keyword signaling question needs deeper reasoning. Why, compare, trade-off, yada, yeah. And then, so this classifies a question into one of the three model roles. So we have the model role, classify. We have a string question normalized to lowercase. Okay, we normalize it, we put it to lowercase, and then check the code. So if it contains any, the normalized contains the code keywords. If it contains any, we put the model as that. If it doesn't, we put as reasoning. Otherwise, put it as fast. So okay, the contains any is a method. Fantastic, man. This is just pretty good. And then the configuration. Now this is where the thing is. This is where the both patterns come together, and it's the most important file. Thank you. We're going to produce a single string bean, a map of model role and the chat client. So the rest of the application will use this lookup. So a map gives us an O of 1 lookup time, if you didn't know, man. So that means I've done data structures and algorithms. So yeah, it gives us that. Inside the method, we go through 3 stages. First, we use the dot mutate on the base OpenAI API to produce a new OpenAI API. Man, whoever named this thing. And then pointed to Grok servers. Second, we mutate on the OpenAI chat model to produce 3 specialized chat models. Okay. Okay, let's see first. First, we use the mutate on the base OpenAPI bean to produce a new OpenAPI AI API pointed to Grok servers. Second, we mutate on the OpenAI chat model. So we have two things, OpenAI API and chat model, to produce a specialized chat model, each with its own temperature, token limits, and model name. Third, we wrap each chat model in a chat client that has its own prompt baked in. So consuming code never, okay. So let's see. We have the multi-model config. Here, we pass the API key for Grok, and then we need the API key for OpenAI. So if you're using two models, OpenAI and Grok, and then we're doing the model role. We need the role and the chat client. So the model role is the key, the chat client is the value. So this is the kind of response that we get. So we have it accepts two params. These are the base chat model and the base OpenAI API. So the step one is it derive a new OpenAI API for Grok. So this is that for Grok. We pass in the URL. See, we've already done this, so we are familiar with what is happening here. And then we have this one here. This is Grok, and then we have the chat. Now we build the chat model. So from the base chat model, we mutate this Grok, and then we pass in the temperatures and whatnot. And then we come for an OpenAI chat model. This is now a coding model. We come to the base model, we mutate, and then pass in the default options. OpenAI, yeah, just similar to this. I wonder which, okay, so the code role GPT-4 with very low temperature. Why code generation benefits from determinism? You don't want your for loop bounds to be created creatively. Yeah, so higher temperature means the model is trying to be creative, but lower temperature means it's very deterministic. And then call, we inherit the base OpenAI API since we're still on OpenAI. Okay, that's fantastic. I have a question for this though. So which one does it? Okay, this one, first model is getting it from OpenAI API, is getting it from Grok, but this one has not specified where it's getting it from. Okay. Why? Okay, it's probably Mo is not understanding. We have an OpenAI API this. Okay, so let's wait for it. So what were we saying? Where were we? So we were somewhere here. So we have this one. Where was I? Yeah, that one we've done. So we look at this other one. OpenAI chat model, this is a reasoning model. So it doesn't also have that. So it just say base model dot mutate dot whatnot. That's okay. And then now we create the chat client. So the first client is a chat client builder. We pass in the faster model. We pass in the default system prompt. And then we build the chat client for that. We build the chat client for this as well. And we also build the chat client for the reasoning. Okay. And then what you're supposed to do is return a map of model role, first client. Okay, we just return a map containing all those things. So we get to the service layer. I want you to notice how short this is. Okay, thank you for that. But let's see if there's some notes here. So because the config already baked every detail, you ask the router. So baked in every detail, model, system prompts and providers, only orchestrate. So here we're just doing the orchestration. So pay attention to what The service does not contain. There are no modern lamps, no temperature, no API keys, no system prompts, no reference grok to, yeah, yada yada yada. Okay, so we have the smart assistant service. So we create a private static final logger. This one smart. Okay, that's fantastic. Dependencies, we inject them. So we need a model router. Where does it come from? Model router comes from, yeah, the model router that we created. We inject it, and then we also did this one. We get the client. So smart service, we pass in those ones, inject them using the constructor, and then we answer. We ask a question, and then we step one, classify the question into a role. So role equals to router.classify. So we classify the question. After classifying the question, we get the chat client. We get the model role. Okay, let's see, something is not adding now. At bin, something is not adding up. Yeah, classify. So classify returns a model role. Okay, fantastic. Yeah, model role. Yeah, you get the chat client. So we pass in the role. So remember, it's a hash map. So the lookup time is O of 1 because you're using the key. We get a start time. This is just like trying a bunch of things. And then step 4, the actual LLM call, Spring AI, using the chat client API. You do the dot prompt. So we have the answer is equals to this. And then, yeah, that's ideally it. And then this is the answer, how we want the answer to look like. Man, this is so crazy, man. So I guess I'll have to implement this and then push in a repository so that you guys can also check it out. So once it's already like very clear. But this is so nice, if you ask me. 52 minutes, wow. But yeah, this is how I use AI to learn. So I just like expose myself to this kind of things, and I'm really excited I got to learn this because now I can go try implement something out of it, which is really interesting. I love Spring AI as a framework. So the rest, let's ask that do that. So we just inject that, and then this is crazy, man. So I guess what I'll do is I'll just sit down and well, I'll just sit down and start implementing this thing step by step. Oh, this is so pretty, man. So why the code model doesn't need its own OpenAI API? So great catch. Yeah, it means I'm learning. Or it's just the model trying to encourage me. This one is for those details that seem inconsistent at first glance. So reveal something important about how the mutate pattern works. So the core principle mechanically and using it for real understanding. So let's see if we look if this other one was doing the same things or hallucinating. You see, these ones are using this one, man. They were using, they were using, or because it's different. Maybe it's because of different variation. So the fundamental rule to internalize is this: you only need a new when you are changing something that lives at the transport layer, the URL you're sending request to, or the credentials you're authenticating. You do not need a new open API when think of as a pre. No, 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 no. I'm pretty sure this is jargon. Yeah, but I'll try to understand why they do that. Yeah, this is crazy why they do that, because they are saying we have this grok, and then we pass this is the first the first model, and then for this chat model, the code model, we don't pass. I don't see uh, why in the first uh, in the first model you passed the what was it called, the open API, but in the second we did Please answer it faster. My viewers are waiting. So the difference comes down to one question: where is the server? Good follow up. So you're asking exactly the. Thank you, man. So we pass the open in the first one to the first model because the first model needs to talk to a different server, Grok server, than the one base model which was already configured, OpenAPI server. We did not pass anything equivalent to the code model because the code model talks to the same server. Oh, okay. So we only pass when we need a different server for a specific thing. So yeah. So when you call the mutate on the base chat model, Spring AI gives you a builder that is populated with all of these base models existing settings. Think of it as getting a photocopy of the base configuration of that you can edit before calling the build. Anything you don't touch stays exactly as it was in the original. So the question of every .mutate call is what am I actually changing and what do I want to leave alone? So for the first model, we need to change two things compared to the base. First, we need it to send requests to Grok's URL instead of OpenAI. Okay. I get it now. I get it. Yeah, fantastic. So it's just like changing. Man, English. Um, so we're sending requests to Grok's URL instead of OpenAI URL and authenticate with the Grok API key. Second, we want it to use the Llama 3 model with a specific temperature and the token limit first, and the first change lives inside the OpenAI. Okay, fantastic. And then passing the options, yeah, and then yeah. So because that's what the model name and temperature. So we touch both during mutation. So OpenAPI, we pass in the grok, swap this transport piece, and then the default option swaps out the fantastic. And then for the code model, we only change one thing compared to the base model. Name, temperature, and the token limit, which all live together in the chat options. We do not need to change the URL or the API key because the base is already configured to hit OpenAI and we still want to hit OpenAI, so we have the transport piece. Okay, I get it now. I get it. I get it. Thanks my guy. Thanks my guy. So yeah, that's ideally it. So this one, oh my god, where you are? Where are you at? Yeah, so this one you don't change anything. We use the parent model. Yeah, we use the parent model, and then this other one we are using Grok, the Grok API. So it's still under OpenAI, but we're using the specific one from Grok. So I guess now everything. So I'll possibly package this application and then put it so that you guys can also access it. And you can see we have the Grok Grok API key, and then we have this one here. So yeah, that was nice. We've also seen how you can return some of the things on your own. Like you can return a record or an entity, which is nice. Um, we can possibly try streaming the response. So instead of waiting for the whole response to come back, we can stream it. So I'll just come here. Um, can I stream person? Can I stream? Can I stream a person? But that one is not going to come back as an entity. You just have to call it entity dot content. That one is gonna come back as a that one is gonna come back as a string, which is okay. But now, yeah, string. So let me just pass a string there. Okay, so what I'll do is I can't stream that, so I'll stream this one instead. So the stream is a string. Mm-hmm. No. Okay, I see. I see. So you don't call we stream. So we stream. So this is a bunch of, and then This is a Flux. Oh man, I'm sorry guys. I'm sorry guys. So you can, I don't know if this is possible as well. You can do a Flux or a pass. Yeah, so we can't do that. So here I need to say stream. Stream doesn't have that. So you can just say dot content. Yeah. Provided. Okay, okay, I see. So I'll not do stream. I was just testing to see whether it's possible. But it seems like it's not possible. So we just use this Flux for this one. We test the first one and then we can end it there. So I feel like I need to do a live stream, man. This thing is fun, honestly. Yeah, just come here, here and then here. Tell me a story. Tell a short story. Man, I don't know if the model is still up. Let's see. Oh, yo. So it restarted. So as it restarts, let's see if there's something else. So with stream, you just do, you can also stream at the chat response using the Flux. So you say this. Okay. I see. String you can Flux. We'll talk about this later because it seems like something that is a bit conk. The next session, I guess we'll talk about prompt templates. These things here. This one's, yeah, we look at everything in the docs. I don't know how long it's gonna take us to finish all these things, but yeah, we'll definitely finish them at some point. Now, it must take a couple of minutes. Let me try another instance. Okay. Okay. Now this is the beauty of using Olama. So if I was using a model with like GPT or Anthropic, possibly I'll start using Anthropic because I guess I have an API key. I'll start using Anthropic because yeah, this is becoming auto and it's very, very, very effing slow, which is so bad for business, you know. So now you can imagine if you're using RAG. So if it was RAG, you'd be crying. You'd be crying now. So RAG is, yeah, it's a hefty process. So it's normally like, yeah, it takes in a lot. As we do that, let's see something else. We can message metadata. So response metadata, you can pass metadata. But as you learn stuff, it's always good to know where you can use the actual thing that you're learning. Like how I asked the cloud to help me understand where I can use this. So it's quite important that you get where you can use a specific thing. Oh my days. Let me try this one. What? Hmm. I don't know. I don't know what's happening with this thing. But yeah, let me just show you what it looks like to stream. Let me just show you what it means to stream. So hi, how are you? So this is streaming. where you get to see the response as it generates. So I'm just a language model, so I don't know how, I don't have feelings and etc. So this one generated. So it has its own things, man, which is okay. Thanks for watching up to this very end. So I'll just tell Olama bye. Bye, Olama. Yeah, thanks for watching up to this very end. And I hope you learned a thing or two, or three, four, five. Yeah, thanks. Thank you very much. I really enjoy your support. Possibly next I'll do a live a live session, and yeah, so that we get to learn together, and yeah, just get to see how Spring AI does a bunch of things. So I'll push the project. I'll try build the project, or I can go live building the project as well. And then yeah, possibly that would be the next thing I do. Now the next recording I do would be that project. I do it and then push it, and then we can move on to other things that the chat client API does. So thank you for watching up to this very end. Have a lovely day. If this content was useful, uh, just leave a comment, smash the like button, and just share with your circle around so that they can also support the channel. So thank you and have a lovely day. Bye.